Hey, so today, our last day, we're talking about automating Solver. Show me on a scale of 0 to 5 how comfortable you are just using Solver in Excel. 5, 5, 5, 4, 4, 4. Okay, it looks like you're pretty comfortable. So today is not so much about learning how to use it as it is what does it take to actually automate it. And there's some things that are a little bit quirky about it. So let's go ahead and get the Portfolio Optimizer workbook downloaded. This is what that workbook looks like. And this is actually an example that it used to be a running example that I used in this class to do various different things. So it used to be that when we're talking about user forms, I would have some data here. You could click on the add tickers and it would just bring up a form with some different things. You could like put the tickers in here and they'd come back onto the worksheet and so forth. So there's a lot here that's kind of beyond what we're doing in this class for. But here's the idea. You give yourself an arbitrary set of stock tickers. You then say, go ahead and get the data. Now, the way that we get the data is by using a service called AlphaVantage. Have any of you ever used AlphaVantage to get data before? No? So you can get a free API key, which will let you make like 500 requests a day. So if you all click this, don't do it, but if you all click this button, we would run out of capacity just here in this room. So, but if you wanted to get your own, because that's my API key and it's limited to those 500 a day, it's the free one. If you wanted to get your own free API key, you could just follow this link and then you could kind of look through the code to see how I'm using that. And it's one way to be able to get data, from a financial service. So we're not going to do that, but what that would do is it would bring in this data that it pulls in from, it's a historical data from finance.yahoo.com. And it's just, oh, I'm sorry, this is like one page of it. I think we've got, the consolidated sheet is the one that we're really after. So what this does is it gives us monthly changes in the stock price. So what this number says here is that for American Express, whatever period of data this is, and presumably it's the date we specified here, so 2012 to 2019 is the range that we're looking at. And here's the tickers that we have here. American Express is the first one. On this consolidate page, it's got American Express, and that says from the month before, whatever this first number is, American Express was up 1.4%. It was up 4% in the next month. It was up 8% the next month. It was down 15%. Is that what that is? It was down 15% the next month. It was down 9% the next month, and so forth. So these are month by month changes in the stock price. And so the idea here, the problem that we're trying to solve is trying to say, listen, given a set of stock tickers, I want to be able to optimally allocate the portfolio such as to reach an expected return. I'm going to say, this is the expected return I'm targeting, and I want to do that with the least risk possible. So I want to look at the volatility that we have in all of these stocks, and I want to say, well, based on a constraint of what return I'm expecting, I want to allocate the portfolio so that it is going to reduce the variability in the expected outcome. So this is the base data that feeds into that. And again, the code is here to pull this data in, like for a different date range. Don't take the time to run it right now in class. So what this summary page does then is it looks at all of this data, and it then builds a correlation matrix. So it's, if we were to kind of look at this, we would say, which of these, if you're kind of looking at this table, what would you say, what are two of these stocks that tend to move together? In other words, when one's up, the other one's up, and one's down, the other one's down. I'm just kind of looking for a large, the maximum correlation coefficient would be 1. Here's one that's almost 0.5. Do we see a larger one? So this kind of makes sense. This is Oracle and IBM. They're pretty highly correlated. When Oracle's up, IBM tends to be up. When Oracle's down, IBM tends to be down. We don't have any negative correlations in this data. That would mean what? Yeah, when one goes up, the other one tends to go down. But we do have some that are not very closely correlated at all. What's our smallest one? 0.17. See something smaller than that? Just give me the two. Give me the two. Give me the two tickers. Apple and Southwest. Here we go. So yeah, 0.08. So those are not very correlated. A slight positive correlation in those numbers. So the idea then is that this summary page is going to allow us to be able to say, hey, we want to have some diversity in the way that these stocks tend to perform. We then have the average return over this period. So if I was to look at this, this is just the average of the column called AXP, which is this column here. And that should have, whoops, that should give me that named range. Yeah, so that range there, that's the range named AXP. And so on our summary, this is just our average. That's the average return over that period. So IBM looks pretty flat over that time. GE is a little bit down from the beginning to the end, or on average, they went down that much every month. Okay, so just some, and then the standard deviations for that same data. So then here's our model. This is where we're going to do the optimizing. So the idea is that we want to be able to change this range here. Like, let Solver play with how much to weight these each of these stocks. So right now there's 10 stocks, we're putting 10% into each one. That's summing to a full distribution of the portfolio. So now, if we look at these means here, what does this mean? What do these means tell us? Go ahead. Right. So if I'm just looking at that historical data and using that to say that's my best guess about what's going to happen going forward, then I'm looking at my expected return. What would be the highest expected return I could expect from any allocation of this portfolio? So who's our highest one here? Maybe I'll just put some conditional formatting on that. Conditional formatting, color scales. There we go. Okay, did that help?
I think you have to reverse the color scales.
It's backwards though, so we want for yellow. That's our highest one. Southwest is our highest one. Huh. So Southwest is our highest one. So is there any way that I could expect to get more than 2.4% return on this portfolio? No. And what would I have to do? How would I have to allocate this stock to get an expected return of 2.4%? I'd have to put it all in Southwest. So, but if I say, you know what, I don't need 2.4% monthly in return, I'm glad to have a little bit less than that. Then I've got some flexibility about what I would choose. And that's the problem that we're trying to solve. We're trying to say I only need to have 1% monthly return. Allocate this portfolio such that it will minimize the volatility in the overall portfolio. So minimize the risk. And our measure for volatility right here is going to be our portfolio standard deviation. So this is a measure of the overall standard deviation from as all the stocks are, the weighted stocks are put into our portfolio. So that's the idea. So let's start off by solving it first, and then we'll do it again. We'll record ourselves solving it, and then we'll get in and work with the code that Solver has generated. All right, so I'm gonna go ahead and open up Solver. That is on the Data tab, and over here at the right. Is there anyone who doesn't have the Solver add-in already installed? You're going to Solver and it's not showing up here on the Data tab. All right, choose solver. And we put in our three things. Our objective cell is going to be portfolio standard deviation. We want to minimize that by changing these weights. Subject to some constraints. All right, what are our constraints going to be? I'm going to add a constraint here. The first constraint is that the sum of my weights here, right here in G7, that's going to need to equal 1. Whatever you put here, that has to equal 1. I'll add that constraint. Now, over here, I've got a line that's actually showing the constraint on the mean return. And that is that this cell right here, D10, has to be greater than or equal to, change that to greater than or equal to, and then we'll put here our required return. So this is our required return. That's just keyed in right now as the full amount. Well, that's something that will change. And then this is the actual expected return from the portfolio, the way that it is currently organized. Now, are those the only constraints I need? Those are the only ones that are coming to mind at the moment. Let me go ahead and say okay. Make unconstrained variables non-negative. I think that's good. GRG nonlinear. I couldn't tell you the difference between the different solving engines here, so I'll just accept that one's the default. Let's solve it and see what it tells us. It says solver found a solution. Oh. Yeah. And the solution is not a very good solution because I said that my constraint on return has to be whatever this maximum one is. So let's move this down to 0.01. And then I'll solve that again. So this is here's my expected return from the portfolio, the way it's distributed. That's now my expected return. So I've loosened this constraint. I'm going to solve again. That looks a little bit better. So that says I can achieve a 1% monthly expected return by allocating this. It's pretty interesting to me that like my highest performing stock like goes right out the window. Don't even put any money into Southwest here. And these then are the allocations that it came up with for the rest. Okay, so that's solving it by hand. Now let's get into the code to solve it. So the first thing to realize is that if all I wanted to do was automate kind of a fixed size model, like I wanted to change this parameter and run it multiple times, like solve it, change it and solve it, I could do it in a much simpler way. I could do it just by saying, hey, this solver is set up, just solve. Like literally just tell it to solve, change the value, solve again. Well, where the problem is going to come is that if the size of this problem changes, now things like the range, like the constraints that we're going to put in are going to have to be different. The range that a solver is allowed to play with is going to have to be different. And so we are going to record ourselves setting this up from scratch. So let's go ahead and turn on the recorder. Go to my developer tab, record macro. Macro name, I'll leave it as macro1, that's fine. Put it in this workbook, no button necessary. We're going to move this code around. And I'll start recording. So I'm going to record myself making the modifications. So back to my data tab, open up solver. I'm going to start off by clicking on reset all. And I got an unexpected error. I guess it was an expected error. It wouldn't have done anything. Oh, that was really unexpected. Closed Excel. Anyone else get that same thing when you clicked on it? Thank goodness. Okay. Let me go ahead and then there's hope that we can get back there. It doesn't seem to remember the file that I had open, so let me pull it up. All right. So macro recorder, set those defaults, data, solver solve. Solver, solve. Okay. So reset all. Reset all solver options. Yes. Didn't crash. That's good. Now I'll just record myself plugging all these things in. So objective cell is portfolio standard deviation. I want to minimize that by changing the weights. And I'll add those same two constraints. The sum of weights needs to equal 1. And my expected return has to be greater than or equal to my required return. An interesting thing here, I just want to notice that this kind of put in an equal sign, that this constraint is actually a formula. That's going to become important to us here when we start looking at the code. Go ahead and say, okay, I've got those two. Unconstrained variables, non-negative. The rest of these defaults should be fine. I'll click solve. Say okay, and then I'll stop recording. Now that should have created a new module to record that. So I'm going to look for module 2. And let's just take a look at what this produced. Okay. Did you get this model sheet, select this sheet, or was that something I recorded inadvertently? Whether you have that or not, you're going to need that because you can only manipulate the solver on the active sheet. So if you're going to manipulate the solver, you've got to activate the sheet where that solver model is built. You only get one solver model at a time per worksheet that you're on. And so like all this is assuming that the active sheet is the model that is one that has the model you're trying to manipulate. Okay, this one looks pretty good. Solver reset. That's just going to reset the options in the solver. Now, let's look at this next one. It's kind of a weird name, solver okay, but we can see the parameters that it has is we're setting the destination cell D14. That's my portfolio standard deviation. The next argument is max min val. So I said minimize, so apparently 2 means minimize. We could record ourselves looking at 1 and setting to a value to see what the other ones are, but that means minimize. We are not setting it to a value, but it still recorded that value of 0. I'm going to leave that there. And then by changing. Now, you'll notice that this by changing is like this hard-coded address. Well, it turns out the code that generates this model, because the model changes sizes depending on how many tickers you have in it, that code actually names a range called weights. If we go look at that range, like if we select that range, you'll see that that is named weights. And that size will change when the model changes sizes. And so rather than having this fixed to that size, I'm just going to change that to 2 weights. I'm going to yell it, apparently. And I'm going to bring this up onto the same line. It's using engine number 1, which is that GRG nonlinear. So not too bad. This is setting up like 2 of the 3. Anytime I've got an optimization model, there's 3 things I have to do. I've got to set the objective. I've got to say what it's allowed to change with, and then specify the constraints. So this has done 2 of those things. It's set my objective, and it's established what we're allowed to change. Okay, now we're going to look at this next one, solver add. Okay, so we're adding a constraint. And here's the relation. What we said was G7, that's our sum of weights. And in fact, that one I think may be named as well, but it's going to be the same no matter where it goes. Yeah, so it's called sum of weights. I may just go ahead and actually name it sum of weights just because it's going to be a little easier in my text, so like to read my code. But that one wouldn't matter. It could stay at that fixed reference. And again, it's, we have several choices here. It's going to be equal to, greater than, or equal to, less than, or equal to. So 2 must mean equal to, and we set it to 1. This one's going to be a problem. We're going to see the problem, and then we're going to come back and fix it. And then we add this next one, cell reference D10. Is that one named? Yeah, that's called the mean return. So let's change this one to be our mean return. Has to be greater than or equal to our required return. Now, these next two lines should look vaguely familiar to us. And why they show up here, like recorded multiple times, I don't know. Right? This is the same one that we modified up here on line 1. And so I'm just going to go ahead and get rid of both of these. They don't need to be there. It's already set. And then solver solve is what's actually going to do the solving for us and tell it to actually go ahead and run. Now, solver solve takes an argument, user finish, which is a true or false. So when you solve, usually a dialog box comes up and says, hey, this is what happened. We either found a solution, we didn't find a solution. That's it. So when we solve, we now have this parameter, user finish, which is true or false. What do you think we're going to set it to if we want it to not display that dialog box? User finish. Would that be false or true? I can never remember, but it seems backwards from the way it's supposed to be. So because you said false, I'm going to put true. And if it shows up, then I'll just come back and change it to false. So it's one of those two. But I think true is going to say, it seems backwards. User finish true sounds like the user should be finishing it, but I think it's the opposite way. All right, so that should give me, and I should be able to run this. Let me come back here and change my required return. Change this down to 0.01. Yeah, I still had like the 0.02 there because I had to reload. I'm just going to run this and see what happens. Okay, so it looks like, yeah, it didn't put that message box up. Let me put this to false and run it. Yeah, it puts the message box up. I don't really want to see the message box, so true is the right one. But is there any problem? Look specifically at G7. Is there any problem? Yeah, didn't we have a constraint that said, hey, solver, as you're changing these things, it has to be 1? And we did. But remember that this is a formula text. And as bizarre as it's going to be, I'm going to have to put equals 1 in there for that to be respected. I have no good reason for why it records this way. Now, how many of you have ever looked at what the macro recorder records and went, wow, that's a really weird thing to do? You know, hopefully that's everyone. You know, that's the macro recorder that was written by Microsoft. This macro recorder here is actually written by Frontline Systems, the company that makes Solver. And so, yeah, there's some things about it that are even stranger. And this is just one of them, just records that in such a way that it won't work. But now I think that will solve. So let me go ahead and run it again, but I'm just going to make it to where we can see it happen. Yeah, so now it respects that. Why it needs to be an equal sign there and it doesn't need the equal sign for this named range, I don't know. But it's respecting that. I wonder if I can change it. I bet I can put the equal sign in there as well. Let me just see. It looks like it can take the equal sign there as well. Let me move this down to like 0.05 and see what happens. Interesting, but 0.05. Oh, I want 0.005. There we go. Yeah, so it's still solving, giving me different numbers. It looks good. Okay. Questions on like the basic recording that the macro recorder records for solver? So what I'd like to do is I would like to integrate this code into this into this problem. So here's the idea. I would like to say, listen, don't just run this once, but I would like to write code that will take me from my minimum return to my maximum return and actually run this solver multiple times. So in other words, let's start this off at the minimum return. Like if I took an expected return lower than this, yeah, I could get something lower, but it wouldn't ever actually choose something lower because it doesn't know how to allocate this and go lower. So it would be at least that. And then ultimately, I want to end up at the highest return I can expect, but I would like to get like 10 or 11 observations along the way from the lowest expected return to the highest expected return that we can get from this portfolio. And solve with each one of those numbers. Now, those should give me then, each one should be a different expected return, and there should be some different volatility that I should expect in that portfolio. And so I'd like to put that information over here onto the frontier sheet. So I'd like to say, all right, when I have a particular required return, I want to see what's the portfolio standard deviation for that required return and what are the weights that led to that. And then I would like to chart the required return from against the portfolio standard deviation. And if I can build this chart right, it should build the efficiency frontier. That point along which I could be anywhere, this portfolio would allow me to be anywhere on that curve or to the right of it, but I don't want to be to the right. If I go to the right of the curve, then I'm accepting more risk for a given level of required return. So the idea here is set up the solver to have a low required return, solve. Move up the required return a little bit, solve, and record what it did. Move up the required return, solve, and record what it did. So let's take a look at the code that we're going to integrate into. Okay, so I'm going to come back to module 1. And here's build model. So build model just does like the major steps, summarizes the data, configures solver, runs solver, finds the frontier. So our config solver is empty. Our run solver is empty. Our find frontier, it looks like most of the work is done for find frontier as well. I can see that I'm looking at the minimum return, the maximum return. I'm going to increment across that. It may be completely done. We'll have to run it and see what it does. So let's go ahead and just kind of bring our code in to configure the solver. I may go ahead and just, so I don't have to go back and forth between the modules. I may just copy the whole thing in here and put it in config solver. So whenever I configure the solver, I'm saying, listen, select the model sheet. Can't manipulate the solver unless the sheet that the solver is on is the active sheet. Reset the solver and do these next 3 things, but I don't want to solve it. So the solver solve doesn't go here. Where does it go? Run solver. And the idea here is that I really only need to configure the solver once. That's going to get it, built with all the constraints that we're going to use. And then I'm going to set a required return and then run the solver. Change the required return, run the solver. Change the required return, run the solver. That may do it. Let me look at where we're building this chart. Make sure that we've got building the chart here. I think I want to put a stop just before we build this chart over here and find frontier. Just want to make sure that this looks right before we go to build the chart. And I'm just going to go ahead and, I think my solver is already configured, but I'm going to go ahead and run it, make sure that it configures okay. That looks like it configures all right. Let me go ahead and run my solver solve, move this up again to like 0.01. Run solver solve and make sure that it runs it. I guess I wasn't paying attention, but I think it did. 0.015. Solver solve. Yeah, running. I just must have not looked quick enough to see it change. Okay, so I'm going to run Find Frontier and let's see what it does. We can see it clicking through that, changing it multiple times. When it ends up on the maximum return, it's allocated everything to Southwest Airlines. It's the only way that it can get up to that highest return. All right. So now, yeah, set S equal to, it's adding a chart. I think I'm definitely going to want to be on that chart first. So before we do that, let's go ahead and activate that chart. That sheet is called Frontier. Oops, does it actually have a name here? Yeah, it's like sheet 43. So let's say sheets frontier dot activate dot select. I'm going to run that line. And anytime I build a chart, I think I need to have that chart data selected first. So let's make sure that we have B3 through C14 selected. B3 through C14. And that'll be the same regardless of how many stocks are in the portfolio, because what Find Frontier does is it makes 11 measurements. It starts with the first one, and then it moves with an increment of 10% of the way up to it starts with the lowest possible return up to the highest possible return. So let's just select that range. I'm not quite sure what that box is. Oh, I got the add chart. I added the chart before I selected it. So let me stop that. Delete that chart. And let's put the selection in before. I'll move my stop down just before that. Make sure things look right. There, so I've got it selected. Now that sheet is active, it's selected. I'm just going to step now and see if that chart looks like it. I'm going to generate with some numbers on it. We're changing the type. Still didn't quite get it right. So what I need is an XY scatter chart. This is O as a challenge. We're setting the data range there, but it was selected when we built the chart. XY scatter with smooth markers. Oh, this looks wrong. Like my data doesn't look right. Maybe the chart is correct for this data. So let's go see what we did, what we missed. I don't think we're actually bringing over the data yet. So let's go do that. All right, let's just follow through this code. Sheets frontier range, portfolio variance. Looks like it should be. I'm going to step from up here. So my increment is 10. So we're going from 0 to 10. Range required return value. So we just plugged in our lowest required return value. Let me go check on my model. Okay. So we better do this. I think the problem is that we weren't actually on the model when we ran it. The model sheet wasn't active. So let me make sure that when we're solving, we're selecting that sheet as well. So when we say run solver, let's make sure that model sheet is selected. It looks like it is trying to copy that data over. Let me try to run that again. That's what we wanted to see. Okay, so now it's run the solver each time with this required return, returns that variance, and then these are the weights for each one of those runs. You can see that on the very last one, like it has to push everything to Southwest Airlines to get that expected return. And so this graph then is showing me that there's no way for me to get to the left of this curve because this is plotting, let's see, which axis is which here. So it looks like I'm going up to 0.08. So this is along this axis is my risk. And then here is my expected return. So where do I want to be on this chart? Yeah, I definitely want to be on the line because to be to the right of the line, there's no way to get to the left of the line. I can get to the right of the line, but that means for a given amount of expected return, I'm taking on more risk. So I want to be somewhere on the line, and like the place where you're probably your best bet is kind of somewhere around we're to bring a line tangent to that curve, that slope of that line would be about 45 degrees or something, kind of right in there where I want to be. I haven't taken on too much more risk to climb, but now as I get up into this part, I'm climbing just to a little bit more return and taking on a lot more risk for every little bit that I'm climbing up. So that's the idea behind portfolio optimization. This class is not about portfolio optimization. I'm the wrong person to teach you anything about portfolio optimization. It's just getting the solver, like to automate the solver to do a task over and over again. Questions? We've got like a half hour and I'm done talking about solver. Any questions not on solver? Anything else you'd like to see? Any of your hopes for this class that were not realized that we can do in the next half hour? Yeah. Oh, yeah. So the question is, this is optimize button here. And let's just, let's see if I can assign a macro to it. Yeah, it actually is already assigned. So that's just going to run it's going to run the run solver method. So rather than having to go and run the code, you could say, I'm change this down to 0.01 and optimize, and it should just run that. So yeah, and that's just, whenever I made this example 15 years ago or something, you would just so you could click that button to run it. All right, why don't we go ahead and conclude with a few concluding remarks? But there's a question. So the exam, I took the exam to the testing center today. They were thrilled to get it. And so it runs during the final exam period, but if we've got something wrong on Learning Suite, let's correct it. Let's see. So, so this looks right. 12 to 16, is that no, that's not right. Let's see if we can fix that. Edit item. When is the th through 20th? ends on the 16th, ends on the 21st. Thank you. It is in the testing center. That's right. Final exam, exam preparation day, final exam, final exam.
It's comprehensive.
Okay, that's a good question. It is comprehensive for a couple of reasons. One, university policy is that I give you a comprehensive final exam. Two, it's comprehensive because we couldn't, I mean, stuff we covered in the first half, you can't do the stuff in the second half without knowing, how can I give you a test that doesn't check to see if you know variables? That's like foundational. But it is heavily slanted to stuff that we have learned since the midterm. I think there are probably only 2 questions where I'm like actively testing something that reaches back beyond the first midterm. So yeah, you definitely want to spend your time focusing on what we've covered since the midterm. There are 31 questions, and they are kind of allocated about like the midterm was. 31 is shorter than the midterm. Why? I just got tired of writing the test. It's like, I'm so tired of making up questions. Would they hate me if I didn't make them do more questions? Go ahead.
Study guide it talks about like
Okay, so let me just bring the study guide up and take a look at it.
so should we know in terms of like changing it to a zip file and then going in?
No, you won't need to know anything about that. You just, I'm gonna give you like XML, like that's there, and then it's gonna be like, here's a button. Like when you click on that button, what sub procedure is it gonna run? Could you look and tell? Could you look at that and tell? How would you know which one it runs? On action is the one that it runs, yeah. And I might ask you, what's it going to show on the ribbon? And that would be by looking at the label, right? So yeah, it's not intended to be. It's intended if you came to class that day and you followed along, that should be easy points. I'm kind of always surprised at like the percentage of the class that does poorly on that one, because it's straightforward. Like look at it, says on action. That's the name of a macro. That's going to run the macro with that name. So other questions for the final? Interestingly, yesterday I had a student come by my office, said, Professor Allen, I took your class years ago as an undergraduate student. Now I'm getting my MBA, but I just want to let you know that like my career like got off to a great start because of VBA. Did a few things that really got me noticed straight away, and it kind of put me on a different trajectory. On my way to this class, a guy bumped me in the hall. Hey, Professor Allen, I took your class in 2017. I'm not even sure why I was on campus, but I guess he still does some kind of landscaping business. And he's all, back then I wrote a thing to send out all my bills in VBA, and I still use it to send out my bills, to my landscaping clients. So yeah, just like this week, it's unusual for me to get like 2 comments from former students in 1 week, but that's what happened this week. So, so a couple of things on that space. Number one, I would like to hear from you when you do something great. So you do something that gets yourself noticed with VBA, drop me an email. That'll be great. The second thing is that wherever you go from now, you will be the VBA expert in almost any circle that you're in, which means it might be frightening to some of you, which means people will be like, hey, you know what? We had an intern who wrote something here. He was from BYU, by the way, and he wrote something in VBA and it stopped working. We're not sure why it stopped working and no one knows how to fix it. Can you take a look at it? So that's a difficult situation to like figure out someone else's code. So when you find yourself in that situation and you just can't get it figured out, feel free to reach out to me. I don't want to feel like I was your first line of defense, but yeah, don't like kill yourself trying to get it figured out. Reach out to me. Chances are, like when you like either call me or email me. Like the problem that you're working with is probably going to be way more interesting than whatever else I'm doing at the moment. So like it's common for me to go, oh yeah, well, do you have time? Let's look at it right now. So yeah, I would kind of be glad to be a resource for you with VBA as you're going forward in your careers. All right. Well, oh, you know what? Did I put anything on the Learning Suite about giving some extra credit for doing the course evaluation? Oh,
Yeah.
good. It's good. Good. Do the course evaluation. And I think there's a little check mark that you have to mark that says, let my professor know that I did the evaluation. And that's how I will know that you did that. And then you'll get that extra credit for doing that. All right. Oh, and by the way, if you ever go to like Rate My Professor, do they still have the chili pepper on Rate My Professor? I don't know if they still have it, but they do. When you're looking at that chili pepper, you're going to go, he's overweight, he's bald, he's old, but he wears the robe. So where's the robe? All right, folks, thanks. If you have any other like individual questions, come see me. It was a great semester. Good luck on the exam, and I will see you sometime in the future. Class dismissed. You're retaking it, okay. Oh, hey, one more thing. Hey, I'm looking for a TA to start next semester. My ideal TA has at least 1 full year before graduation. So if you think you'd be interested in TAing for this class, I just need 1 more to apply. So send me an email and I'd be glad to work with you.